We'll focus on two main things today when we talk about distance in the coordinate plane. First thing I want to know is, just between 2 points, how could we calculate the distance? What do you think one way could be? Well, counting, yes. That's a good skill. How long have you been counting? Seems like forever. Yes, long time, right? Some people kindergarten, some people before kindergarten. So at least for some of you, it's been, a good 10, 11 years that you've been counting. Some of us, like me, much longer. What would be another way, do you think? We could measure the distance between two points. Oh, I just said it. Find the distance between 2 points. We could measure. And those are really pretty much the two ways we will do. The question with measuring is how. How is that going to be done? That's what we have to figure out. Well, let's take a look at these lines. Line BC. How could I find the distance between B and C? Get the coordinates? Okay. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's negative 12, 1, 2, 2. And this one is 2, 4, 6, 6, 2. Okay, I got the coordinates. Now what? Add them together? Nope. That's an idea. Eventually we're going to in the formula. So once we get a few other steps done, then we will add them together. I will eventually. Yeah. Adriana says, hey, let's use the distance formula. It'll work. The distance formula will work. That's not what I would use, though. Nobody thinks of an elementary way that you've known something to do for a long time? Count, whatever. Thanks. That's what I would do. The way humans work is, if you can do something easy, you're much more likely to be accurate in doing whatever you're doing. Counting's pretty easy. You can do it. I mean, you could use your fingers if you want. I don't want to see any shoes coming off, but just reuse your fingers. Start back over. But if I'm going to find the distance here, I'm going to count. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's 18 units from point B to point C. How would you find the distance from E to F? Same way, count, right? Okay. 1. Now notice, I start at E, but I don't count 1 till I get to the next square. Why not? What, counting? Yeah, it's easier, but when you start to measure a distance, would I say 1, or would I say 1 now after I step? After I step, right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 units, this line. So that's how we found the distance on these two. We just counted. It worked, didn't it? Yes, very effective, very easy method. How would I find them for those? Either one of those lines. Count how many it goes through. Count how many what goes through what. Goes through what? Please, be my guest. I mean, if you want to show me how you're going to count that, please. Come on up, show me. Anybody? Blocks. Blocks which way? Because I can count the number of blocks it goes horizontally, but then I have to count the number of blocks it goes down. And that doesn't give me one number. That gives me a certain number over it, a certain number under. All right, where are my geometry people that love geometry? What could I do, Brandon? What could I make? Ah, yes! Bonus points for you, sir. I could use the Pythagorean theorem, right? If you've had some geometry, and make a triangle there, and this is the hypotenuse. I'm going to use the formula, the Pythagorean theorem, a squared plus b squared equals c squared, and this line right here is my c squared. Yeah, you could do all that, right? Or you can use the distance formula. Right there. You know what, though? That's the Pythagorean theorem. Backwards. That's solving for C using two coordinates. So essentially we are using the Pythagorean theorem. If you don't know what the Pythagorean theorem is, has anybody not had it and at least heard of it? Okay, it was created by this dead Greek guy named Pythagoras. He found that if you have a right triangle, if you take the length of one of the legs and square it, plus the length of the other leg and square it, it equals that length of that diagonal line, the hypotenuse, squared. So you find the length of that line by taking the sum of those two and taking the square root, which is aren't what we're doing here. This is it. So this is what we're going to use to find the distance of any line that has any kind of slope to it. So before we get to that, might we come up with a general rule? We didn't use those for these two lines. Why not? Because we could count. What kind of lines are these? And I almost said, whatever you do, don't say straight line, because all lines are straight. If it's not straight, it's not a line. What kind of line is it? If it goes like this, it's horizontal, and the other one is vertical. Good. This is a horizontal line. This is a vertical line. So we're going to have a rule. For horizontal or vertical lines, you just count, because it's easier. You can use the distance formula, but you will not impress me. You will do the opposite, because a really intelligent person would know to take the easier way to do something, because as a human being, we're much less likely to make a mistake, so we will be more accurate in our work. Remember, it's more important to be accurate than it is to be fast. So, if you have any kind of line that is horizontal or vertical, you're just going to count the number of squares. It's these that have some kind of slope where we have to use this special formula. Has anybody seen this before? All right. You know what this little 2 here and this little 2 here does, right? What does that do? It squares it. It takes whatever number's inside here and multiplies by itself. Has anybody ever seen when the variables have these little letters down, little numbers down below? Has anybody seen that before? Yes? Science class, okay, yes. In mathematics, the way I would read this is x sub 2. However, when you have the little 2 or the 1 or any number that is a sub below that, it has no how do I say this? It has no arithmetic value. There's no calculation to perform. It does not affect the number. What the little 1 and 2 below tell you is it is a coordinate on the coordinate plane. It's just telling you it is a location. Because without that, here's what we would have. What's x minus x? 0. Any number minus itself? 0 squared is 0. What's y minus y? And 0 squared is 0. 0 plus 0 is? What's the square root of 0? So it doesn't make much sense, does it? So without that little sub 2, what you have, and the sub 1, is just a variable. When you see the sub 2 or the sub 1, what you need to think in, as if you would think anywhere but in your head, but what you need to think is, I have a coordinate. It is not an operation to perform. It is just a coordinate. What I want you to notice now, so here is an example of a coordinate, x and y, correct? The little 2 here and the little 2 here tell you that that x and that y come from the same ordered pair. And the little 1 under the other x and the other y, it means they come from the same coordinate. So what this means is when I go to calculate the distance between any 2 points, I pick an x, and then I take the other x, and then I take a y and the other y. So you put the 2 x's together and you put the 2 y's together, subtract, square, add them, square root. So the last step in this formula will always be square root. It looks complicated, doesn't it? It's not. Works a lot worse than it is. Let me walk you through it very slowly. I want to find the distance between m and n. m is at 4, negative 6, n is at negative 2, 3. The first thing I'm going to point out, that's an x coordinate, this is a y, this is an x, this is a y. Most common mistake made when students do this is they will stick both the x and the y in the same parentheses. You cannot do it. The first one are for the x coordinates, the second one are for the two y coordinates. Ready? So I'm going to have the square root of, which one of these is x sub 2? Doesn't matter. You get to pick. Because it doesn't matter. You can make either one x sub 2. The other one automatically becomes x sub 1. There's only one reason why it's important. Are you okay? You okay? You look like you're in pain. Okay. Just really not enjoying the lesson? Just really not enjoying the lesson? Okay. It looked like you had some bad gas or something. Your stomach was about to explode. I get to pick which one I want to make x sub 2. Here's how I do it. I don't know why it is, but I always like to have a positive number out here in front if I can help it. So I would make this one my x sub 2. The important thing to know is this. Whichever x number goes first, the y that is with it has to be the first one in the other parentheses. If you don't do that, then your numbers will be wrong. You'll end up with the wrong y coordinate. So since this x was first, the negative 6 will have to be the first in the second parentheses. So here I had 4. I'm going to subtract. I'm going to subtract a negative 2 and square it. This was the other x. Plus, this has to be my first y since the x that was with it was the first x. Negative 6 minus 3. That becomes plus. Now I add these two. 4 plus 2 is 6, and I'm going to square it. Plus, negative 6 minus 3 is negative 9. I'm going to square it. Now, after this next step, which is going to be squaring those two numbers, should I ever get a negative number? Can you square something and get a negative number? No, it's impossible. If in this last step you hit negative square of a number and hit a negative, your calculator is going to give you error, and it should. It's impossible to take the square root of a negative number. Not to mention you shouldn't have any because you're going to square them right here. It should get rid of all the negative signs. So I square them next. 6 squared is 36. Negative 9 squared is 81. Add those two together. Square root of 117, which you're going to have to figure now. You will get decimals. That's okay. Not a big deal. 117 square root 10.82. So the distance from this coordinate to this one is 10.82 units. So if I graph that, 1, 2, 3, 4, I'll go back. 1, 2, 3, 4, 5, 6. This was m. Negative 2, 3. Oops. Oh, I went the wrong way. It's 4, negative 6. Two, 3, 4. M should be over here. So I just got to move my line a little bit. That distance right there from M to N, that's 10.82 units, which there's no way you could have counted to have gotten that. It's impossible. You have to use the distance formula. Have to use the distance formula, which, as Brandon pointed out, really what it is starting off with C, the hypotenuse, and just working backwards given two coordinates to find the distance of A and B. The distance formula, if you're thinking in terms of the Pythagorean theorem, define c squared, you have to take square root of both sides, right? So that's why you have the square root at the end. So that's what c equals, is that. So there's your geometry for you. All right. So far so good? Because I'm going to throw another formula at you now. So that gives us the distance between 2 points. To find the distance halfway in between the 2 points, this one's a lot easier. This is the midpoint formula. How do you find the middle of anything? Yeah, divide it into, yeah, cut it in half. Look what's happening here. I take my 2 x coordinates, right? X sub 1, x sub 2, they're just coordinates because they have the little sub in there. Divide it by 2. Take my 2 y coordinates, divide them by 2 after I add them together. Why is the parentheses, why is the comma in there? What's my answer going to be? Something comma something. What do we call it? An xy coordinate, correct. Look, when we're finding the distance formula, you are finding a number right here, a distance. In the midpoint, you're finding a coordinate on the coordinate plane because you're finding the middle point. So if line segment AB has endpoints 2, 3, and 8, 5, what is the midpoint? I put it into parentheses automatically. X, here's my X, here's my Y, here's my X, here's my Y. Notice I'm labeling them. That might help in the beginning if you do that. 2 plus 8 divided by 2, and 3 plus 5 divided by 2. The order here does not matter because you're adding. So you can add in any order. That's 2 plus 8 is 10 divided by 2. 3 plus 5 is 8 divided by 2. So my midpoint would be at the coordinate 5, 4. If I graph that, those 2 lines, found the midpoint, it would be at 5, 4. Here's what we can do with this stuff. We can do analytical geometry, which is taking some geometric based stuff and then using some rules of algebra to justify why we're getting what we're getting. The vertices of triangle ABC are at A04, B00, and C40. Classify this triangle. What does it mean to classify it? We're going to give it its name. Remember, there are 2 ways to name a triangle. By the length of the side, which should make sense why we're learning the distance formula, right? And by the properties of the angles. After we classify the triangle, we're going to find the length of the hypotenuse. All right, let me graph this first. 4, 0, 1, 2, 3, 4. Here's A, B is at 0, 0, and C is at 4, 0. 1, 2, 3, 4. Oh, why did I do that? Oh well, that's close enough. How would I find the lengths of AB and BC? You want to use the distance formula or what? No, what do you want to do, Adriana? What kind of lines are the 2 legs? One is vertical, the other one's horizontal, right? So what should we do? What was our first rule? Count. If it's easy, do it. This is a vertical line, so I can count. I just count the number of units. 1, 2, 3, 4. So that length is 4. BC, 1, 2, 3, 4. That is 4. What kind of triangle do we have there? What kind of right triangle? Isosceles right triangle. It's isosceles, 2 legs are the same length. Is it equilateral? No, this line's definitely going to be longer. So this is an isosceles right triangle. The second question was, find the length of the hypotenuse AC. This is the hypotenuse. How might we do that? Distance formula. So this is 4, 0. Nope, this is 0, 4. I got it backwards. Remember, first coordinate tells you how many to go right or left. Second coordinate tells you how many to go up or down. This is 4, 0. So I'm going to use those two coordinates. What you'll find is when 0 is one of the coordinates, it makes the distance formula a lot easier. All right. Square root of, I'm going to make this my first x. 4 minus, this x is 0, squared, plus, that has to be the first y since this was the first x, is 0 minus 4 squared. 4 squared plus negative 4 squared. 4 squared is plus, I did not write the radical all the way through, but notice, what does my last step have to be? Got to take that square root. So I just saved myself a little bit of time by not, if you're going to forget doing that radical at the end, put the radical in there. But if you can remember to do that, you can go ahead and skip that. Square root of 32 is 5.6, 5.7, I think. 5.66, 5.65. 5.65 units. So that's the length of the hypotenuse. 5.65 units. And then if I wanted to, I could find the midpoint in that. Find the midpoint of the hypotenuse. In this one, it works out to be easy. It's that coordinate right there. It's 2, 2. But if we use the midpoint formula, 4 plus 0 divided by 2 is 2. 0 plus 4 divided by 2 is 2. So it is 2, 2. The vertices of quadrilateral ABCD are at A, 2, 4, B, negative 5, 2, C, negative 2, negative 1, and D, 5, 1. What kind of quadrilateral does ABCD appear to be? So that's the first question. What does it look like? Unfortunately, in geometry, you cannot just prove something by what it looks like. You have to have some kind of justification. Then we're going to use distances to justify the type of quadrilateral ABCD is. Did it again. A is at 2, 4. 1, 2, 2. There's A. B is at negative 5, 2. Negative 5, 1, 2. There's B. C is at negative 2, negative 1. Negative 2, negative 1. There's C. And D is at 5, 1, 2, 4, 5. There's D. Now, what does that look like if my drawing were a little better? Okay, wow, I got like 4 different answers. It is a quadrilateral. They just said it was a quadrilateral. Thank you, Captain Obvious. What kind of quadrilateral does that appear to be? It appears to be a quadrilateral. Thank you. It's like going to the doctor and the doctor telling you you're sick. Well, I'd like a second opinion. Okay, well, you're ugly too. What kind of quadrilateral does it appear to be? Rectangle has 90-degree angles. Do you see any there? No. Almost. I think these are a little too long. But what we're going to do is we're going to use the distance formula to justify whether or not it would be. I think it's, I agree with these two. I think it's a parallelogram. But we could easily justify whether it is or not a rhombus, right? Because if this length and this length are different, it can't be a rhombus. Rhombus, all 4 sides have to be congruent. So we're going to use the distance formula. If it's a parallelogram, what will I know about this side and this side? They'll be the same. They'll be the same length. Same with BC and AD. And if it's a rhombus, this side and this side would be the same. So I'm going to use the distance formula to start figuring out some lengths here. All right, the length of BA or AB is going to be, well, I need my coordinates. A is 2, 4, and B is negative 5, 2. All right, so BA is, I'm going to start and use this x first and subtract that one, so I'm subtracting a negative to end up with a positive, because that becomes plus. Plus, since this was the first x, the y with it, the 4, has to be the first y, minus 2 squared. Good, and I end up with all positive numbers. 2 plus 5 is 7 squared plus 4 minus 2 is 2 squared. 7 squared is 49 plus 2 squared is 4. It's going to give me the square root of 53, which is 7.2 something. 7.28 units. Now, if this is a parallelogram, CD will be the same length. So let's find the length of CD. C is at -2, -1, and D is at 5, 1. My first x, which x should I pick to be first? Or which one would you pick? 5? 5 minus a -2 squared, that becomes plus. Plus 1 minus a -1 becomes plus squared. So I end up with 5 plus 2 is 7 squared plus 2 squared. Do I need to finish it? Look, this here and this here are the same. Wouldn't they have to finish the same? In theory, yes. If you do the arithmetic correctly, yes, they have to finish the same. So both lines are 7.28 units, so it's at least a parallelogram, right? Somebody else said, hey, I think that's a rhombus. That's easy to check. Let's find the distance of BC. If BC is the same, if it's 7.28 units, we have a rhombus. Do you see how we're using the distance formula then? An algebraically based formula to justify some geometry. That's what Descartes did. He took all the stuff the ancient Greeks said and say, hey, I can do a lot of this stuff with using algebra. Do you see how brilliant this guy was? And he did it all in his head. Give me a headache. All right, let's figure out BC. So B is at -5, 2, and C is at -2, -1. So I'm going to have -5 minus a -2, this x minus that one, quantity squared. So this y, 2 minus a -1, quantity squared. -5 plus 2 is -3 squared plus 3 squared. That's 9 plus 9, which is 18. Square root of 18, well, that's 4 point something. It's definitely not 7.28, is it? No. 18 square root, 4.25. So these are different. Can it be a rhombus? No, it's a parallelogram. So we've now used the distance formula to justify what it was. It's a parallelogram. The endpoints of a diameter of circle P are -110 and 4, 6. Find the length of the diameter and find the center of the circle. To find the length of the diameter, what formula am I going to use? Distance formula. To find the center of the circle, what formula am I going to use there, Chris? Wow. You're good. You made it come out of his mouth and sound just like him. I didn't know you were a ventriloquist. Yes, it is the midpoint formula. So we use the distance to find this and the midpoint to find that. All right, -110. There's the one mid end and 4, 6. Let me draw that diameter, and then I will try and put a circle around it. No promises, though. There, you get the idea. So as my circle, I want to find the distance for the diameter. I can't do that. Why might I want to find the distance for the diameter? When would that be useful? To find what? Circumference, the radius. If I know the diameter, then I can find the circumference. Where might this be used? If you owned your own landscaping business and you're setting out a design for somebody's house, you'll need to know this stuff. And how do you think they grid? They put it on a grid, on graph paper, and do all this stuff. So yes, this does have practical applications if you're designing something. And I don't want to hear there's a computer program that does it for you, because there is, but not everybody uses it. All right, distance formula. Define the length of the diameter. My x-coordinates. So for my x-coordinates, I'm going to take 4 minus a minus 1, quantity squared, plus, then since the 4 was the first x, the 6 has to be the first y. That is crucial. If there are two places to make a mistake here, and the hardest part of this formula is not the computation. That's all simple arithmetic, and I know you all can do that. The hardest part is substituting correctly. There's one of two places you can make a mistake. Either you'll put, a mistake could be put to doing like negative 1 minus 10, taking the x and the y and putting them in the same parentheses, or to invert, like to do 4 first here, but then the 10 for the y to be first there. Those are the two places you make your mistake. Make sure that you substitute correctly. 4 plus 1, 5, squared. Plus 6 minus 10, negative 4, squared. 5 squared is 25, plus negative 4 squared is 16. Square root of 41, just 6.4. So the length of the diameter is 6.4 units, whatever they are. Now to find the midpoint, which if I had to guess looking at this would be somewhere about right in this area. But we want to be precise, so I'll take my two coordinates, add my x's, negative 1 plus 4 divided by 2, then my y's, 10 plus 6 divided by 2. Negative 1 plus 4 is 3, so I get divided by 2 is 3 halves, or 1.5. 1.5, and then my y, 10 plus 6 is 16, divided by 2, 8. So my coordinate for my midpoint is 1.5, 8, which would put it, 1.5 is there, and up 1, 2, 3, 4, 5, 6, 7, 8. Right there. That's my midpoint, 1.5, 8. Questions? Two formulas, that's what you're going to use, one of those two formulas. Midpoint, I'm sure you'll be fine. Just be careful when you substitute for the distance formula. 246, 247, 1 to 30. Skip number 18. 1 to 30. I shortened your assignment.